Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, thanks to be here with me today. My name is Nasik Waranito from School of Telecommunication Engineering Telkom University. Okay, today I will present my paper with the title is Comparison of High Availability Performance on OpenDialect with Corrosing Pacemaker and OpenDialect SDN Controller Platform Clustering. Okay, this presentation is divided to 5 chapters. Those are: first part consists of introduction, second is background, describe the reason behind the paper, third system model and design, explanation that used in the paper, and fourth result and analysis shows the result of the paper with explanation and analysis in detail. And the last is conclusion. It shows the conclusion from the result and analysis that answer the background of the paper. Okay, background introduction of the paper. In order to increase network availability, network management, reduce network operating costs, and develop network innovation that require high availability. As for previous research, it discussed the comparison of the availability of controllers with OSGP clustering and distributed replicate block device. In this paper, discussed about high availability which compares with the OpenDialect or OSGP clustering and crossing pacemaker method to find out which high availability is the best. Okay, the problem formulation of this paper is: first, the effect of using different high availability methods on the failover failback process, and two, quality of OSGP clustering and crossing pacemakers high availability resilience to the number of hosts and switches, and third, the quality of the QoS parameter value for the failover failback process of different methods. Okay, next. This research purpose is simulate the high availability process on the OpenDialect controller using the forcing pacemaker method. Second, testing the endurance of the high availability with the forcing pacemaker to the number of hosts and switches in the failover failback process. And the last, analyze QoS parameters on OSGP clustering and crossing pacemaker that occur during failover and failback process. This objective on this paper: simulate the system, analyze failover and failback, analyze the QoS, and determine best of high availability. Okay, let's move on to basic theory. Software-defined network is a new concept in controlling, managing, and managing computer network that separates the control system or control plane and the forwarding system or data plane on a computer network device. Software-defined network controller is an software-defined network control application that manages flow control to enable intelligent networking. SDN controller works based on protocols such as OpenFlow, which allow the server to tell where the packet was sent. The controller is the core of the SDN network. High availability is a system that has available capability that will ensure that the application will run continuously and not be interrupted by the failure of one of the subsystems, because there is a subsystem replacement process that fails to automatically backup the subsystem. Next, Crossing Pacemaker. Crossing is an open source program that provides cluster membership and messaging capabilities, often referred to as the messaging layer to client server. And Pacemaker is an open source cluster Resource Manager or CRM, a system that coordinates resources and services that are managed by made highly available by a cluster. OSGP clustering or Open Dialect Software Defined Network Controller Platform is a control based on the beacon controller design that provides high availability and grouping support and saves a lot of error that existed in the previous controller. In the OpenDirect controller, there is a control leader that manages the network and has log files that carry information. If in any case the control leader stops working, the follower controller, who also carries the log file, will start working on the network. Next, system module and design. In the model system, there are two controllers, the primary and the secondary controller, which are generated via Mininet to virtual IP. Virtual IP will automatically move if there is a controller that's down. Okay, this is topology on Mininet with 16 hosts and 15 switches, and with topology 32 hosts and 31 switches. Okay, this is system model is compared with the result of visual research. There are two scenarios in the system model. One, failure failover comparison with OSGP clustering and crossing pacemaker, with the parameter output delay, packet loss, throughput, and the other parameter traffic load with 16 hosts, 15 switches, and 32 hosts, 31 switches. And two, fallback comparison with ICP clustering and crossing pacemaker. Parameter output is delay, packet loss, and throughput. And other parameter traffic load 16 hosts and 15 switches and 32 hosts, 30 to 31 switches. Okay, next, result and analysis. It can be seen in the monitoring log files. There is a time indicator that shows the time when there is a lot of topology made from Mininet. When there is a displacement in network performance from the primary controller to the secondary controller, the time will appear indicating the failover or failback. Here is the capture after generating background traffic with hyperv in Mininet from client to server with host 2 as the client and host 1 as the server. Okay, this is comparison analysis, time failover and failback. It can be seen that in topology 16 host 15 switch, the crossing pacemaker method is faster than OSGP clustering. This is due to the increasing number of nodes. The load on the controller increases, so that the time needed by the primary controller to take over the network performance of the secondary controller is getting bigger. Next, comparison analysis delay, failover and failback. It can be seen that the delay of forcing pacemaker is much greater than the delay of the OSGP clustering method. It can be concluded that the OSGP clustering method with additional hosts and switches can handle the quality of network QoS better than crossing pacemaker. This is caused by the increasing number of nodes. The load on the controller increases so that the delay obtained is greater, and there is an additional delay of the synchronization process by two different interfaces. Next, comparison analysis, packet loss, failover, and failback. If the more the number of nodes, packet loss is obtained even greater. Packet loss from OSCP clustering is more stable than crossing pacemaker. This is caused by the increasing number of nodes. The load of the controller increases, so that the packet loss obtained greater. Next, uh, throughput. The throughput generated by the crossing pacemaker method is unstable compared to the OSCP clustering. There is a drastic decline in crossing pacemaker. This is caused by the result of the delay in the crossing pacemaker method that is obtained quite large. The greater the delay obtained will affect the resulting throughput. The last is conclusion. The conclusion of this paper: first, high availability using SGP clustering is better and more stable when compared to forcing pacemaker if the controller is on a centralized network. And two, the failover and failback process that occur in OSGP clustering are more stable when compared to forcing pacemaker. Third, the QoS generated by OSGP clustering is better when compared to crossing pacemaker when there are additional hosts and switches. Last, the quality of QoS parameters values generated by the OSGP clustering method is better than crossing pacemaker in the high availability system.